Problem 5. Oops, I was wondering where that went. The figure above shows the graph of f prime, the derivative of a twice differential function f on the interval -3 to 4. And it says we've got some horizontal tangents going on. Great. And it tells me that the areas of the regions of the graph of f on the intervals -2, 1, and 1, 4 are 9 and 12. So they are telling me that this area is 9 and this area is 12, if we find that helpful at some point in time. All right, part A says to find all x coordinates at which f has a relative maximum. So if we're going to find f having a relative maximum, we do want to do an f prime chart. And this is f prime, so f prime to f prime is just looking at above and below. So I'm going to be, my critical values are going to be -2, 1, and 4, which is just at the end of my interval. I am positive, negative, and then negative. So if I'm looking for a relative maximum, where does f prime change from positive to negative? That would be at x equals -2. So x equals -2 is a relative maximum because f prime changes from positive to negative, and that was worth 2 points. If you identified x equals -2, you got a point, and if you were able to say y, you got your second point. Okay, part B. And on what open intervals contained in -3, 4 is the graph of f both concave down and decreasing? Give a reason. So if I'm concave down and decreasing, again, I would like, for decreasing, I want an f prime chart, and for concave down, I need an f double prime chart. Well, we already did the f prime chart. It had -2, 1, and it ended at 4. This was plus, minus, minus. So it could be in these spots because we're looking for decreasing, okay? And then concave down, I want to do an f double prime. This will be the slope. So if I'm looking at the slopes are negative till I get to -1, and then they are positive until I get to 1, and then they are negative until I get to 3, and then they are positive again. So if I'm looking for concave down, it would be in these two areas. So I just need to try to figure out where those match, and I notice between -2 and -1, they're both negative, and then between 1 and 2, they're both negative. Well, actually, would that be 1 and 2? Well, it would be to 3. Sorry, that one ends at 3. So between 1 and 3. So those would be the two places, and that would be because f prime and f double prime are both negative. Okay, that would be worth 2 points. If you identified the intervals, you got 1 point. You had to have both of them to get your point for that one. And then if you were able to say why, you got your second point on that one. Okay, part C. Find the x coordinates of all points of inflection for the graph of f. Well, we already did an f double prime chart. So if we could just recreate that, we'll be good. So we have -2, oh, excuse me. This was -1. It was negative, positive till I got to 1, negative till I got to 3, and then positive again. So points of inflection are where f double prime changes signs. So there are 3 spots. So that's going to be at x equals -1, 1, and 3. And that would be because f double prime changes sign. Right? That was worth 2 points. We got 1 point for the x values. We got 1 point for our reason. Okay, part D. Given that f of 1 equals 3, write an expression for f of x that involves an integral, and then find f of 4 and f of -2. Okay, so I am just going to do kind of an accumulation type problem. So I'm going to assume that this is where we start. So if we start at 3, then I'm going to add up the change in distance from 1 to wherever. So if I want to find f of x, I would just find where I started plus the area under f prime from 1 to some value x, which I'm not sure exactly what that is. I did notice when I check my answers, they always like to use 2 different variables. So if I'm using an x right here, they will just use a different variable for this one. So we might just want to get into that habit to make sure that we are getting our full points for that. So that would be my expression for f of x. So f of x would equal that. And again, that's just accumulation. This is telling me how much I'm changing, and then this is telling me what I'm starting with. So if I would like to find f of 4 now, all I need to do is plug 4 in for my x. So this would just be 3 plus the integral from 1 to 4 of f prime of t dt. Okay, and so from here, f of f prime is just, the integral of f prime would be the area under the graph. So I know the area under the graph. They had told me already that this was 12, however it's negative. So this will be 3 plus negative 12. So f of 4 will equal negative 9. And then to get f of negative 2, it's just going to be 3 plus the integral from 1 to negative 2 of f prime. Well, remember, we can't do that, so it's really going to be 3 minus the integral from negative 2 to 1 of f prime. They told us that was 9, but again, that's below the x-axis, so that will be a negative 9, so it's going to be 3 minus negative 9. So f of negative 2 will equal 12. All right, this part is worth 3 points if you are able to get the integram. So you have f prime in here inside of the integral, you get a point. If you were able to actually write this entire expression, you'd get a point. Yours might look a little bit different, that would be okay. And then if you were able to find both f of 4 and f of negative 2, you got both of them, you got your 3rd point on that one.